Hey there! We are going to tell the stories about Newton, Leibniz, and the development of calculus. The discovery of calculus is often attributed to two men, Isaac Newton and Gottfried Leibniz, who independently developed its foundations. Although they both were instrumental in its creation, they thought of the fundamental concepts in very different ways. Newton considered variables changing with time. Leibniz thought of the variables x and y as ranging over sequences of infinitely close values. He introduced dx and dy as differences between successive values of these sequences. Leibniz knew that dy/dx gives tangent, but he didn't use it as a defining property. Newton used quantities x and y, which were finite velocities, to compute the tangent. Of course, neither Leibniz nor Newton thought in terms of functions, but both always thought in terms of graphs. For Newton, the calculus was geometrical, while Leibniz took it towards analysis.
The development of calculus. Two important factors led to the development of calculus. 1. Interest in questions about infinite process and object. Ancient Greek mathematics was not equipped to deal effectively with Zeno's paradox about infinite, and by the time of Aristotle, it had essentially insulated itself from its horror of the infinite. During the 14th century, the mathematical work of Aristotles and others on infinite series complemented the interests of the scholastic philosophers. Questions about the infinite play a key role in the efforts of scholastic philosophy to integrate Greek philosophy with Christianity. 2. Interest in questions about physical motion. During the 13th century, journalist Leibniz discovered the mathematically correct description for the physics of an incline, and later member of the Merton School in Oxford had discovered an important property of uniformly accelerated motion, namely the average velocity. The significance of this concept for the motion of freely falling bodies was not understood at the time and would not be known until the work of Galileo and others in 16th century. Problems leading to the development of calculus. In the early 17th century, mathematicians became interested in several types of problems, partly because these were motivated by advance in physics and partly because they were viewed as interesting in their own right. The three problems is 1. Measurement questions such as length of curves, area of planar regions and surface, and volume of solid region, and also finding the centers of mass for such object. 2. Geometry and physical attributes of curves, such as tangents and normal to curves, the concept of curvature, and the relation of these two questions about velocity and acceleration. 3. Maximum and minimum principle. Example, the maximum height achieved by a projectile in motion or the greatest area enclosed by a rectangle with a given parameter. Newton's published paper on calculus. The controversy surrounds Newton's development of calculus during the middle of the 1660s. Between 1664 and 1666, he asserted that he invented the basic idea of calculus. In 1669, he wrote a paper on it but refused to publish it. He wrote two additional papers in 1671 and 1676 on calculus, but would not publish them. In time, these papers were eventually published. The one he wrote in 1669 was published 42 years later. The one he wrote in 1671 was published in 9 years after his death in 1727. The paper he wrote in 1676 was published in 1704. None of his work on calculus were published until the 18th century, but he circulated them to friends and acquaintances, so it was known what he had written. This was not just hearsay, and he used the technique of calculus in his scientific work. Leibniz published paper on calculus. Gottfried Wilhelm Leibniz independently invented calculus. He invented calculus somewhere in the middle of the 1670s. He said that he conceived of the ideas in about 1674 and then published the ideas in 1684, 10 years later. His paper on calculus was called A New Method for Maxima and Minima, as well tangents, which is not obstructed by fractional or irrational quantities. It was 6 pages, extremely obscure, and was very difficult to understand.